Okay, so welcome to the long-awaited bouncing ball tutorial. There's a whole lot of these online, and basically what it's going to show you is the principles of some very simple squash and stretch animation and the ability to create these acceleration and deceleration curves in Maya. So what we have here is a ball, and this sphere, which has been given an eyeball texture, is going to become our character, and we're going to be able to create a sense of motion by squashing and stretching this character and creating an illusion that it's generating its own force, its own kinematic force that carries with it an amount of gravity and an amount of elasticity, using the principles of animation, squash and stretch, and exaggeration. Okay, so what I'm going to do here, now we're going to do this in a very simple term. So we have the scale here, so we're able to scale it, and what you're seeing in this ghost is I have a previously done animation. I'm just going to use that as my guideline, and that'll just give me the ability to create these keyframes rapidly in the right sequencing. Otherwise, you would have to figure out the sequencing of your keyframes and timing from the ground up, which a lot of animators do. I'm just going to use this little template that I've already done to help me speed up the process of generating this animation. Okay, so what I want to do here, first of all, is I want to give it its ability to compress itself, right? Now remember, our 5 stages of animation, of an action, based on poses, are rest. So here, let's just make this guy invisible here, and let's bring this guy up here as our reference object. And here is the stage of rest, right? Eyeball sitting there in space. Now we have our anticipation, and the anticipation is generating force, right? I'm preparing myself for an action. In this case, this eyeball is preparing itself to jump up. So it's squishing itself down. And this is what we call squash and stretch, because any object that's going to generate its own force is going to have some amount of elasticity. Now we're exaggerating this using the principles of animation exaggeration. So we're squishing it down rapidly, and then its next stage, so we have this rest pose, anticipatory pose, anticipation, gathering energy, and then boom, it pops up, and top of its arc here, this is our action. This is what we're intending to do, jump up into space. And we're going to fall back down to the earth. Now in this particular animation, we have another in-between pose, which is a rest pose, because it must hit the ground, right? So we add this extra pose, but generally speaking, this pose is not necessary, because what's really going to happen is our action, and then our follow-through. In this case, gravity is going to pull our ball back down to the earth, and boom, it's going to squash itself down. And this is our exaggeration pose. And then pops right back up to our rest pose. And if we play this animation, it loops itself, so it just continuously jumps up and down. But it always exaggerates its anticipation pose first. Okay, so now this one is not perfect. There's a few timing differences. I did this animation quite a bit of time ago, and I've perfected some of these acceleration, deceleration curves since then. So, like I said, we're just using this as a basic template so I can just kind of get a sense of the timing on the keyframes, not having to do it from the ground up. I haven't memorized them, so this makes it a little bit easier for me. Okay, so let's move into our anticipation pose. Now what's going to happen in that anticipation pose? Well, what we're going to do is we are going to squish him downward, and we're going to scale that Y. And let's just change it to our object-based scale. And undo that. You always want to scale things based on the object, not the world. Okay, so I'm going to type in my value here. And I have this idea of I squash and stretch. When I squish him all the way, his scale of Y will be 0.6. But now remember, in a squash and stretch type of situation, we must maintain the volume of this object as if it was a real squishy ball. So whatever amount we remove from 1 for the scale of Y, or add to 1 for the scale of Y, we will invert in the scale of X and Z. So I will be creating a squash that looks like this. And actually, before I do any of this, I'm going to jump back to our initial keyframe. I forgot to set a keyframe for his rest pose. So we're going to go ahead and only going to keyframe the things that we want to keyframe here. So I'm going to select my channels. Translate Y, scale of X, Y, and Z. Right click and say key selected. That is going to create a keyframe at that particular position. In this case, the frame 0. Now let's move forward to frame 6. And what we're going to do is, now we're going to go back to what I did. We're going to squish him down by typing a 0.6 to the scale of Y. And now I'm going to type in 1.4. So by maintaining this relationship, and let's also key this translate Y, right, I'm allowing him to squish down while maintaining his volume. If you notice, the pivot point of his scale is right here in the center of the world, his bottom, right? And I'm doing that because we're squishing him from contact with the ground, right? So we don't want to squish him from the middle. That would not look normal. That wouldn't look physically accurate. Right, so squash. Now what I'm going to do here, it's a little animator trick. In order to accentuate our action, we are going to freeze his pose at his anticipation for a single keyframe. So here I am on keyframe 6. Keyframe 7, I am going to once again just select my channels. Now I'm keyframing these individually. I'm choosing only the channels that I want to keyframe. So we need one frame, and the reason for that is our eye cannot process more than 24 frames a second accurately. So what happens is oftentimes our eye will drop a frame, and it will look like he popped out of nowhere. And when you see the final animation, let's just bring this guy up here. I don't know where my... Oh, there he is. All right, here's my little template guy here. Now, I did not do this for him, and if you notice, from one frame to another, it looks like he just popped out of nowhere, right? There's no solid hold for that anticipation. So what I've done is made a solid hold for this. Just we get 1 second where our eye can register that initial anticipatory pose where he's gathering that energy. So just a little animator trick. You hold on that frame just to exaggerate what's about to happen. So boom, we've got him holding on this frame, and then, and this is where I use my template guy here, going to pick up the point at which, here's my template, he jumps up into space. And this guy seems to be a little slow, so I'm going to squeeze down the time a little bit. Actually, we'll squeeze down the time later. So we want to get this pose happening. This is our, just template him there. This is the pose that we're trying to match, which is his jumping up in space. So when he jumps up, and let's just translate him up in the world, right? And key selected here. Okay, sorry, I got a little interrupted there. Probably going to be a hiccup on the video. All right, so here we are in the pose. This is the action pose, right? So it's jumping up. But of course, when we have an action pose and we have squash and stretch, he's got to reverse what's happened. He's squashed himself down here. Now he must extend himself here. So I'm going to reverse this. I'm going to type in 1.4 for the scale of Y, 0.6 for the scale of X and Z. And this is a relationship, a squash and stretch relationship. You can scale this relationship to make it stretchier or less elastic. The looser the object and material is, the more elastic, the higher the ratio value will go. So right now I'm having kind of a relationship where whatever I add to one, I remove from the other. But there are some other ratios you can look up online for squash and stretch. This is just the one I like to use for this particular exercise. So let's go ahead and scale in keys. All right, so here we have the action pose. I'm going to hide this guy here. So here's our action, right? So he's in his rest pose, in his anticipatory pose, right? Anticipation for an action. And then boom, here's the expenditure of the energy. The maximum expenditure of energy becomes the action pose. And then he's going to fall back to the earth, and let's just get the timing here. Boom, right there, falls back to the earth. So let's translate him, and we'll, because that pivot is at 0, we know that his translate's going to be 0. So it makes it a little easier to figure out where that translate of y is going to be. And now I'm just going to set him back to his rest pose in terms of a squash and stretch. Now, like I said, this is kind of this interim pose, right? And the reason is because as he hits the ground, he's going to decompress a little bit, and then he's going to decompress even more. So we're going to hit frame 34, and just like our anticipation pose, our compression pose will have those same, oops, it's actually going to be 0.6 there, and 1.4, and 1.4. And that's going to squash them down here. Let's go ahead and keyframe that. And I'm just going to keyframe this one too, for some various reasons. And now, at our final pose, the end of our animation here, we're going to take him back to that rest pose. Key those. And now we have the outline of an action. We've and now actually I'm not going to play this because if you watch the play, it's not going to look very good. And the reason for this is we're not going to have the acceleration and deceleration. We're not going to have all the physical stuff set up yet that makes this look like it has weight and volume and energy. We just have the poses, right? So here's our rest pose, our anticipation pose, our action pose, and this is our in-between pose where he hits the ground. This doesn't happen in every pose-based animation, but in this case it will. And then boom, compression, and then decompression. Okay, so now if I play this, now the thing is the first stage of animation is just to create these initial 5 poses. The next stage is to really edit and tweak your timing, right? So I can watch this and see what's happening. The timing is not, to me what I'm looking at is the timing is way too slow. Now, one of the things you're seeing here, which looks a little weird, is he's jumping upwards before he finishes decompressing. We're going to fix that later. But essentially what's going to happen is that decompression, right, has to happen before he leaves the ground. So the way this is set up is he's jumping off the ground while he's still compressed, and it's going to look very odd. We're going to fix that when we set up our acceleration and deceleration curves. But it looks odd because we don't have this set up quite right yet. But what I'm saying is I just feel like the entire animation could use a little bit of scaling downward. And so what I'm going to do is, now here is my graph editor here. I'm going to bring up this dope sheet. And let's scale out. And let's see. Can we scale an entire animation? Yes, it's very easy. I'm going to select all my keyframes. I'm going to go to my scale key and bring this, squeeze this in a little bit till my final frame, instead of being at 30, is at 37. Now I'm going to, and I'm maximizing this because there's kind of a bug in Maya that doesn't really like to play the animation very fast when you have the dope sheet or the graph editor open. Okay, now even though it looks bizarre and odd and reads totally weird, I can see that to me, the timing on these keyframes works a little better. Okay, so our next goal is to edit our tangents. So we've done 3 things. We set our key poses. Select this guy here. We've adjusted our timing. And now we need to adjust our tangents. Why? Because all this weird looking stuff here, it looks very mechanical, right? The tangents are what keep this from looking mechanical. And I'm going to bring up my graph editor here. And we're just going to look and see what our tangents. Remember, the tangents are what change these curves. And in animation, we have these keyframes that we've set. Now, we've set the keyframes in a very intuitive way by clicking over here and changing the values and setting all those key stages in a natural what I consider found an intuitive pose-based animation system that makes you understand what's happening here from pose to pose. Now what's happened as we've created those keyframes is that it's saved those marks and times, and here's our keyframes, but the computer has to interpolate, and the interpolation happens in between, it looks like all these keyframes, because I scaled it, they're not exactly on frame to frame, which is really, really annoying when, let's just select all of these. It's really annoying when you're working, so I'm going to snap these. When you scale intuitively, the biggest problem is it does not snap these, and it still doesn't snap them. Let's go ahead and it should be snapping it to multiples. It does not want to snap everything. Let's try snapping these independently. And here's 6. I'm just going to have to do this manually. Luckily, we don't have too many keyframes. One of the things that I didn't mention is that when you scale things and you don't scale it exact, you scale it a percentage, I'm just going to squeeze it down, it tends to take keyframes and put them on fractional keyframes, and I hate fractional keyframes because it puts a frame on something like 6.5, and it's because it has to do that with the values. Now you can set this somewhere that doesn't allow fractional keyframes, but I've forgotten where it is, and I don't want to waste time during the tutorial trying to figure that out. So I just went in and made sure that they're all at a frame of 1.0 in an integer, and not at a float. Okay, so let's look at this. Here's our translate of y, and you can see the curve as we're looking at this curve data. You can see here's where it takes a leap upwards, right? So this is the y. The y curve is the easiest to read because it's the up in world space. So here's the value. So the computer's interpolating based on this tangent, which is a Bezier curve with these handles. So when we edit these handles, we create a sense of acceleration and deceleration, which creates more of a physical dynamic animation. It creates a sense of movement and weight. Right now we don't really have much, and just as an example, we have several different types of tangents. This is what we call a flat tangent, which means there's an ease in and ease out curve. Just select this here. Right, so this flat tangent creates this ease out, so the rate of change increases and then it decreases here. Right? We could select this, which is our linear tangent, and we can make all of our tangents linear. Right, and this would create no ease in and ease out curve, and this would look very robotic. It's really hard to see with that graph editor because Maya is really bad on the Mac. It's bad at displaying animation with the graph editor, which is, with the graph editor present, it just really slows it down. And this looks so mechanical. Why? Because we're not getting any sense of motion, exaggeration of action. This is a character, and he's got his own method of locomotion. He generates his own force and power. So now what I want to do here is use that. Let's just go here. I'm going to switch this back to the default here is flat tangents because it creates the most pleasing overall universal effect for animation, but it creates some pretty boring animations. So what we want to do is figure out where this is going to accelerate and where it's going to decelerate, and when we do that, we'll create the illusion that this is a physical being that has weight and volume and can generate its own force. So the first thing we want to do is say, okay, well, if it's going to squish down, right, it's going to accelerate downwards. It means the rate of change is going to increase from this point to this point. Why? Because it's generating power. It's increasing. It's squishing down really fast. And then it freezes for a second, and then it pops up, right? And it's going to accelerate up to the point. So every time it decompresses, it compresses or decompresses, it's going to happen at an accelerated rate. So in order to do all this, we're going to have to do a couple steps. We're going to select all of these tangents. And I'm selecting, let's just select all of them. Sometimes in a certain animation we can just do all of it at once. So let's select all of it. And let's go to, first of all, let's turn on, go to curves, turn on weighted tangents. That just turns the weight values on. It doesn't free the weights, but it turns them on instead of not having weighted tangents. Now we're going to go to our tangents and free the tangent weight. This allows us to change in a very, very customized way our weight tangents. And the third thing we're going to do to everything except, so we'll do this to the scales, but not to the translator Y, just because I don't want to. Well, we'll do it to everything. Why not? All right. I can undo it to a certain part. I'm going to go to tangents and break. That means that my in and out tangent can act separately. Now, if I unify the tangent, select this one, and go to tangents unify, whatever I have selected, that if I change the weight of that tangent, it'll change equally on both sides. And sometimes we want that. In this case, in this spot, I want them to be equal. Okay, so let's look and see. Now this is a squash and stretch curve. Now remember what we do to one curve, and the X and the Z are in the exact same spot because they have the same values. And then the Y is the inverse, right? So this is our squash and stretch relationship, kind of looks like a DNA. Okay, so let's accelerate this from its initial point. So we want to accelerate the rate of change. And to do that, we select our tangent values, and we're going to have to select these to peel them away. What we do here to create an acceleration curve, actually we're going to do that down here. We can do it here. We select that curve and make it 90 degrees. So I'm going to make that tangent 90 degrees here. And what that's going to do is accelerate the value. So the rate of change will accelerate. And man, it is hard to see. It's happening so fast, it's going to be a little hard to see. And because it's happening so fast, I might just decide to move some of these keyframes over just a bit. I'm selecting these with my shift key held down. I'm just going to maybe move all of these over a tad. Just one frame so I can get maybe just a little bit more time. Sometimes we adjust our timing after the tangents because alright. Now one of the things that's really hard to pre-visualize, what's happening is it's squishing itself down faster. So the rate of change is increasing. And what's really important is the rate of change between here and here, and a couple different things. And let's look at it from alright, if I could see what the hell is happening here. What we want to do now is, first of all, we're going to create some hang time in the air. And hang time is that it's going to jump off, but it's going to slow down as it goes upward. Right now, it's an even change, a rate of change between these points and these points. What I want to do is create a bell curve, and that bell curve is going to create the illusion of hang time. So I'm just going to select my tangents here, and we're going to create this 90 degrees. This is usually how you do things. You always tweak this later, but in order just to set up the initial acceleration and deceleration, using this 90-degree angle is really helpful. And now I'm going to, because I've unified this tangent here, I select my tangents and spread it outward. It's going to create this bell curve. What's happening is it's going to accelerate quickly, and then it's going to hang in the air, and then it's going to accelerate down. And that's what generally what would happen if we had a ball, because as you go upward, And you can see how it's hanging in the air a little bit. Now, we're still having some problems with it popping up in the air being squashed. Now, that really wouldn't happen. What happens is, by the time it leaves the ground, it has unsquished itself. But we're going to fix that right now, because we're going to create that same change in our scale of x and y. Because between here and here, zoom out there, right, we've got a whole lot of leeway, and we want to make sure that this curve, instead of being this ease out curve, is actually the opposite. So we want these curves to be deceleration curves. Now what that means is it's going to change that value rather rapidly. Now you can see from here to here there's a whole big difference. It's popping off rather quickly. But because it's such a short period of time, we may not have a problem reading it. The longer time we have between these two frames, the more we'll see change from here to here. Now, traditionally what will happen actually from this point to this point, and I might just edit our frame here. Maybe we'll see what happens if we get rid of that pause. No, we definitely don't want to get rid of the pause. Just squish that down a frame. Okay, so now we're starting to get a little bit better. In that one of the things I'm seeing is I'm getting a very poor response in my video card, probably because I'm in the midst of recording, so I'm not getting the greatest response time here. Probably because the recording software is going. Let's just move that one over too, so we have them all lined up. Okay, now the only thing I have left to do here is, let's check these here, is decide, okay, well here is the deceleration curve, right, here. Now, remember we have to do the same thing on the other side, and in this case, actually, we're going to do this. I'm going to select the scale of x and z. Make sure these match up here. And then we'll do the same here. So you see how everything's matched up, almost like a DNA. All right, so now that we've done that, and maybe if I turn the shading off, it'll speed it up a little bit. A little bit. There's a lot of hiccups. It's running very rough because I've got the recording software going at a high resolution. Now the only thing left here to do is when it squishes down, so we've hit this point, now you would imagine from the point of contact we're going to get an accelerated squish, right? It's going to squash down at an accelerated rate because force, gravity, and force is causing that increase in value, or increase in the rate of value. And that's happening really slow. Alright, so let's just, so right, I want to create an acceleration curve, squishing it downward. So it's going to squash down pretty fast, right? It's not going to stick and then squash down. It's going to go, boom, it's going to squash down. And let's see if and create that deceleration curve. Actually, let's do an acceleration curve here. I'm just matching the x and z. And reversing that. And the question is, how springy is this material? Is it going to accelerate back into its original position, or is it going to decelerate? And it looks like as it hits the ground, I see here that there's a sticking point, and that sticking point hits the ground, then squishes. And really, it shouldn't do that. And so we can kind of like focus in on our little problem area and see that, all right, it's created this. We've essentially created an acceleration curve down to this point, and then a deceleration curve here. So we've got this point here where we might want to just delete those keyframes. Now you notice how much less of a sticking point there is. That's just a little trick. If there's a point where we don't need that transition, then deleting those keyframes really helps. I'm struggling with the slow speeds of the display, but there you go. Now, if you try it on your own, you're going to get a much better result in terms of the display. And you can always tweak a lot of these values. Some of the values you can tweak to change. Let's just bring it down and translate Y here. So some of these values you can change will change the physical properties of this ball. Obviously, the lower the translate Y, basically the heavier this object is, because gravity will start working on it at an earlier pace. But also, the sooner gravity starts working on it, then you can change the scaling of that, which is going to be a little too slow for me to do here. So now, even though it's trying really hard to get high, it's not, and the reason is because it weighs a lot. Let's say this is a fat ball, so I can even exaggerate this more by actually, I take that back. Let's do it 0.5. I'm going to exaggerate this effect here, and let's just keyframe that. So now, you see how it looks a little smushier? And once again, we're losing a lot of frames here because of the recording software. But like I said, the lower it goes here, the lower it is at its arc, the less kinetic energy it created. So it tried really hard, and actually another little trick here is we can even make it squash down more. I'm just going to keyframe that, and then we'll change this to 1.6, 0.4, and 1.6. And you'll see that what happens is it's going to squish a whole lot, but it's not going to get very far. We could even bring it down. This is going to be a little easier if we just tweak. A lot of times it's a lot easier just to go ahead and tweak this value. Let's bring it way down. And we're just creating a physical effect here, right? And the physical effect is that it's a heavy object. It's trying really hard, but it's not getting very far. Why? Because it's really heavy. And we're exaggerating the motion to make it look as if it's heavy. Okay, so that's a rather long-winded way of explaining how we create dynamic animation. So the process is we created those poses, right? Here's the pose. Here's the energy expenditure pose. And notice the higher it is, the higher energy was generated, or the lighter the object is if we have gravity working against it. Here's the second rest pose. Here's the squash. This is the follow-through. And this is the rest pose again. So rest, that's our anticipation, action, and really isn't a rest pose in between here. We just have to create a point where it hits the ground. But here's our follow-through, and here is our rest again. And now, once we created the poses, we worked on the timing, squishing the timing down. Does it move faster or slower? And we can always tweak this timing to make this object look faster or slower or stronger or lighter or whatever. There's a lot of play that we can have in between the timing here. And then what we did is we edited our tangents to create our acceleration and deceleration. And let's just create this consistency. And that acceleration and deceleration is what really sold this as a living, moving object that physical forces are working on. Alright, so that is the bouncing ball tutorial.